calculate the derivative of a cosine omega t plus alpha, no, phi plus phi, where a, omega, and phi are constants. This is omega, looks like a W, and this is phi. It's also same thing as phi, so they're used interchangeably. And a, omega, and phi are constants, so this is something to keep in mind. Now, if you're wondering about these numbers and why they're placed like this, it's because I claimed that to do this problem, you only need three things. You need to know three things. And these things are these derivatives. So if you want to retry the problem, you can try to pause it, use those hints, and combine all of these facts to get the final solution. So this is what, effectively, this is what we were going to do right now. So the first thing is, if you want to take the derivative of a times cosine of omega t plus alpha, then we're taking the derivative of, this is equal to the derivative of the product, because you have a being multiplied by cosine omega t plus, I hope I didn't say phi, plus alpha. And so, what this is telling us is you'll fix one element and take the derivative of the other, and then switch, and then add the two results. So if we want to find the derivative, we would fix a and take the derivative of cosine omega t plus phi, and then take the derivative of a and fix cosine omega t plus phi. But then I'll draw your attention to something, and that is a is a constant, and the derivative of a constant is 0. And fundamentally, the derivative is the rate of change, and so a constant does not change. So this is actually equal to 0. And if you're multiplying this by that, then actually the whole thing is equal to 0. So from the start, we didn't really have to consider this. Okay, that's good. So if there's a constant, we just act like it's not there. And so now we are tasked with finding this derivative. So we want to find this derivative here. And I gave it a different color because color coding is important. So this derivative of the cosine, you need to notice again, well, you can guess it now, it's a composition of functions. So you have the derivative of cosine of x, but it's composed with omega t. Well, I wouldn't say, okay, maybe just, I'll use t as well, there's nothing wrong with that. And then omega t plus alpha. What this means is you plug in this into that. So this is effectively cosine of wt plus alpha. So that is what it is. And so if we have this, and we're taking the derivative, then it's number 3. Then this is going to be, by number 3, we're composing two functions. We take the derivative of the outer function, so the derivative of cosine, just the derivative of cosine cosine, just like here. So we take the derivative of that, and then we compose it with g, which is the inside function. This is the inside function. So we compose it with omega t plus phi, and then we multiply this whole thing by the derivative of the inside function. So the omega t plus phi, but you take the derivative. And it seems like we're making some progress. So we just need to compute the derivative of cosine, or we do not, because it is literally given to us right here. But we do indeed need to compute this derivative, because we have not computed it yet. So I'll do this on the side. The derivative of this is the derivative of omega t plus the derivative of alpha. Phi, I'm sorry, phi. This is phi, this is not alpha. And alpha is a this is getting very silly. And phi is a constant, so its derivative is 0, just like we did here. And here, if you want to take the derivative with respect to t, then the derivative of t is 1. And the constant, we just let it be as it is. We don't need to consider it. So again, considering the derivative of t, and the derivative of t is 1, because you can write this as t to the power of 1, then if you apply the power rule, you get 1 times t to the 1 minus 1, which is t to the 0, which is 1, which is 1. So this is actually just omega. Okay, that's good. So everything's getting closer and closer. This purple part by number 2 is equal to the minus sign of t, but we still need to compose this with omega t plus phi, and then on the outside we multiply by the derivative, which is, in this case, it's omega. Now I hope you don't mind if I take this power, not power, but the minus, I'll just put it outside. Then I just need to plug this in, which will give me a minus sign of omega t plus phi, right? And then you're multiplying by omega again. But then what is all of this? This is that derivative. Then if that is the derivative, and then we just need to multiply it by a, and we're done. Because this is 0, and we need to multiply this thing by a, and then we're done. So I hope you can distinguish, because so far we've been computing this value on its own. So that's very important. And I hope you can see and learn something from this decomposition that we've constructed. And this is a very important skill, because if you want to make progress with difficult problems, you need to know how to break them down into simpler problems. As you can see here, I'll take this derivative, which is equal to that value, and I'll multiply it by a. So I'll put the minus outside, and the omega I'll also put it on the left. This kind of convention to put the constants on the left, and in that case, that would be your answer for the question.